So let's need to discuss the phase changes and the phase diagrams. But I'm done with the phase changes, okay? Because this phase changes is related also to the phase diagrams. Okay, something that I need to draw now. Okay, I will take example only for water and alcohol. Okay, something like that. Wait for a while. Oh my God. Okay, I need to draw this. Guys, wala akong kuhan. Little pen. Where's my pen? Oh. How can we do this? Okay, nawala siya. Okay, guys. But before that, guys, we need to discuss also the different phase points. PHASE. Okay, for example, first we need to know what is the bubble point. The bubble point. Okay. The bubble point, okay. Ganun siya. Okay, the dew point. Okay. Dew point, okay. Dew point, DEW point. Okay. We have the boiling point. The freezing point. Okay. The freezing point. The melting point. Okay. Like that. We have the tripole point. Okay. We have the critical point. Okay. We have also the flash point. We have also the auto ignition point. We have the explosion point. We have the fire point. Okay. So before going to the phase diagrams, we need to explain this one by one. And you need to understand this, okay? The bubble point, the dew point, the boiling point, the melting point, the freezing point, okay? The tripole point, the critical point, the flash point, the auto ignition point, the explosion point, and the fire point. These are points in science, okay? And you have to understand this one by one. Okay, guys? So what do you mean by a bubble point? Okay, a bubble point, it is a temperature at a given pressure with the first bubble, okay, form of the vapor during boiling of this liquid with two or more components. For example, if you heat or you boil a certain substance and the first bubble will occur at its initial stage for the very, very first time, that point in time that's called bubble point. Actually, this is very obvious when you read a paragraph or sentence, but okay, but sometimes if you don't have an idea, for example, if the question is not a multiple choice, fill in the blanks, you can never answer that one. For example, blank is the temperature at a given pressure in which the first bubble of the vapor formed during heating and boiling of this liquid with two or more components. Oh, no choices. That's already bubble point. If you don't have any idea, or you cannot answer unless there's a multiple choice, because your identification is the bubble. Okay, A, bubble point, B, dew point, C, boiling point, D, melting point. But you will be also confused to the boiling point, because during boiling point, the bubbles also will form. Okay, so you are not really sure, you are just guessing, something like that, if that is the case. But it's also an additional technique to discover the term first, because usually also the processes, whether it is a chemical change or a physical change, the term itself will speak. Okay, something like that. For example, you condense. Okay, you condense the vapor to form liquid by cooling, something like that. Okay, that is condensation, right? And then your term will be condense. Okay, you'll say, oh, my product will be condensate. Okay, no, it's not. It's the reverse. It's the distillate. Okay, it's confusing, right? Just like in chemistry. Okay, if this substance will cause other substance to oxidize, that is reducing agent. Okay, in the oxidation and reduction, something like that. Okay, so that's gonna be like that also, the reverse. Or just like the anode is the positive terminal, reverse, and the cathode is a negative terminal. But the definition is not reverse. So just like this also, okay, you will cool, okay, you cool the vapor to produce a liquid. That's distillate. Okay, you cool. Okay, and then you also heat the vapor. The reverse will do that. Okay, you also heat the liquid to produce the vapor. Okay, of course you will heat the liquid, not the vapor, by common sense. It's easy to say, evaporation, we need to evaporate or we need to heat, okay, the liquid to produce a vapor. Okay, if you produce a vapor, your vapor will be the condensate. But condensate, the root word there is condense. Okay, so supposedly it is in the process of condensation. You get the point? But the product is reverse. You get the point? Again, when we mean of evaporation, when we evaporate the liquid by means of a heating, of course you need to evaporate, you apply the heat, right? So it will produce a vapor. So that is a condensate product in distillation. Okay? It's not the process of condensation, so it's heating. Now the reverse will goes through. Okay? If you condense, okay, the vapor, something like that. If you condense it and it produces a liquid through cooling. Okay? You are condensing the vapor, you collect the vapor in the distillation column through the, shall we say, reflux drum, something like that, okay? And then it will go to the, first it will go to the condenser, and then it will go to the reflux drum, and then it will go, the reflux will go back to the distillation column, and then the rest of that will go to the distillate as a distillate, something like that, okay? So distillate will be your product for that, for the condensation. Okay? So, the product of the condensation is always liquid. Ganun na lang siya. You think of that because condensation is a change from, ano man siya, gas to liquid. So, kung liquid ang product, condensation na kita siya. Okay, that's why we have condensed milk. Okay, when you see inside the milk that is liquid, right? So, everything that is condensed, that is liquid. Okay, not the condensate. Okay, because sometimes you will be confused also, okay? Me also a lot of times. My gosh. Okay, so these two process, evaporation and condensation, apply in the distillation. Okay, because this distillation is a separation process, okay, based on the volatility, okay, and its boiling points, okay, for the vapor and for the liquid. Of course, the vapor will go up and the liquid will go down because the liquid has a high density compared to the vapor. You get the point? That's why we need to heat so that it will become lighter and will go up. Okay, so after heating, then it will produce a very light molecules. Okay, because of course, if that is a large molecule, it will never go up. So it became a light molecules. Then the boiling point also will become less. So lower boiling points will go up. Okay, large boiling points will go down. Okay, something like that. So that's the principle of distillation. Okay, now going back, what is a dew point? Dew point. Dew, D-E-W, let's say we have mountain dew. Oh, ganon. What do you mean with dew? Okay, so this is really when the air must be cooled, okay, to form with a water vapor. To form a water vapor. Something like that. Okay, again, vapor also, ha? Okay, so the air must be cooled. It is a process in which the air must be cooled, okay, so that it will form as a water vapor. Okay, so it is a dew point, meaning vapor also is the product, not a liquid, but coming from the air, not coming from the water. Get the point? So that's dew point. Okay, number 3, what is a boiling point? Okay, boiling point is very easy when the vapor pressure or the pressure of the vapor will be equal to the pressure of the liquid surrounding. Okay, meaning of this liquid surrounding, if you have a container, there's a liquid surface, right? That liquid surface is the surrounding that we referred to. So if that pressure on the liquid surrounding that surface will equal to the pressure of the vapor at a certain temperature, which is 100 degrees Celsius in case of water, that is boiling point. Okay? It's very clear. That's the same definition to other organic and inorganic liquids. Okay, you can easily determine. That's why we can easily determine the boiling points. Okay, even though there's no value given. For example, which of the following has a lowest boiling point? Because usually you are just confirming that, okay, by an experimental evidence, right? No need to do that because the theory will hold. You get the point? For example, in the examination, which of the following chemicals has the lowest boiling point? Okay, A, ethanol, B, carbohydrates, C, gano'n, di ba? Nucleic acid. D, sa pa na siya dihang mga chemicals, let's say, petrol. Nakakaloka. Okay? Hydrocarbon, something like that. And then, compute for the molecular weight and for the molar mass. If the choices, compare the molecular weight of the choices, the one that has a lower molecular weight, that has the lowest boiling point. And the higher molecular weight or molar mass, that is a higher boiling point also. Okay, we see also, if we reverse also the question, the theory question, if we like this, which of the following needs more kinetic energy to boil? Again, choices again, A, water, B, ethanol, D, petrol. Okay, and then there's no data, there's no figure. That's theory, okay? So if you understand, then bingo, you can answer. Of course, you need more kinetic energy to break the atoms of those substances and chemicals at a very high molecular weight. Okay? You get the point? So choose the chemicals or substances that has a very high molecular weight means it needs higher kinetic energy. The reverse will hold true. It needs a lower kinetic energy. Okay, if it is lighter or has a lower molecular weight or molar mass, something like that. So it will work. Okay, that's theory. Okay, so number 4, freezing point. Andito na naman tayo. Okay, what do you mean by absolute zero? Okay, sometimes we will say at absolute zero, for example, only the entropy of a perfectly crystalline solid will always equal to 0, according to Mr. Simon Nern's theory in third law of thermodynamics. Okay, something like that. So, what do you mean by absolute zero? Absolute zero, guys, what we refer there is Kelvin. 0 Kelvin. Okay? So if the problem also a question in the examination will say, at absolute 0, what is the value of blah 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 like this? So take note already that the 0 degrees, 0 Kelvin, not Celsius, not Fahrenheit, not Rankine. Okay? Like that. That's why at absolute 0, blah blah blah, at standard temperature and pressure, mga chupa-chucho. Okay? Like that. Okay, except for the ideal gas. The ideal gas standard temperature is 0 degrees Celsius. Okay, 0 degrees Celsius and standard pressure 1 atmosphere. Ganun siya. Okay, but the other topics in science, the standard temperature is 25 degrees Celsius. Okay, and at the room temperature. And then another also special case for the computation of the density. Okay, because our reference there is water. Our density of water at standard condition is not measured at 25 degrees Celsius. It's measured 4 degrees Celsius. That's why we have 1 gram per milliliter, 1,000 kilogram per cubic meter, 62.43 pounds per cubic feet, the value of our density of water at 4 degrees Celsius, not 25 degrees Celsius. Because naanad ta kay 25 degrees Celsius ang standard per me. Kaya mo man siya gamiton pero sa mga enthalpy, mga heat of formation, sa physical chemistry, but it's not. Exemption ang density. Okay, because water is a pure substance. So, kung hindi mo follow sa 25 degrees Celsius, ilahi man yung value. Okay? At the point. But the pressure is just okay also. At 25 degrees Celsius. Okay? Example, at 25 degrees Celsius, the pressure, the pressure of water, the pressure of pure water is 23.8 torr or 0.0317 bar. Okay, so water siya, common kaya siya. May siyempre may pangitaon. So, if that is the case, in examination, at standard condition, then you need to look for books or handbook. You get the point? You can easily detect, oh my gosh, this is 23.8 torr, 0.0317, bar. Okay? If you have that kind of mentality in facing examinations, more or less you will pass the examination. Okay? Kailangan makag-retain sa inyong brain cells. Okay? Because the theory will be used also in problem solving by Yapit Shah. Okay? Ganon. Now, freezing point. What do you mean by freezing point? Freezing point is a temperature, specific temperature at which the liquid will turn into solid. Okay? The most common example for this is when the liquid water turns to solid. And all inorganic and organic chemicals has its own freezing point. But the most common, again, is the water. Pure water freezing point is 0 degrees Celsius. Okay? Kung grabe na dyan ka siya kadahil, it's less than that. Kung negative siya, but 0 yun ang yung freezing point. What I mean, kung grabe na dyan ka ka-ice ba? Okay? So 0 degrees Celsius, standard. And then, 32.2 degrees Fahrenheit. And then 273.16 Kelvin. For example, examination will say, What is the freezing point of water? A, da 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 da, B, da 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 da, C, da 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 da, like that. So many choices. Okay, so your answer could either be 0 degrees Celsius, 32.2 degrees Fahrenheit, and then 273.16 Kelvin. Or if you can convert that to Rankine, then you can have also another freezing point standard in terms of Rankine, in which you will multiply the Kelvin to 1.8 only. Okay, multiply na to ang 1.8 to 73 on the spot. Okay, and now we have additional value freezing point of water in terms of Rankine just now on the spot. Because I did not memorize this when I was in high school. Okay, I only memorized the 3 when I was in high school. The freezing point of water. Usually the water and the air, the most common I memorize, not the others. Okay? Sige, ito mo, memorize din ako, tanan, no, it's not. Okay? Yung makabuang siya kay potassium, daghan ng chemical substances. Okay? So, 273.16 times 1.8. So, 492. So, the freezing point of water, okay, is 492 degrees Rankine. Okay, if the choices in examination in terms of Rankine, because there are 4 units of temperature: Rankine, Kelvin, Celsius, and Fahrenheit. And you must be aware also each formula to be used for that, so that you will never find difficulty in actual problem solving in the future. You are not dependent with the books, whatever. In the examination, there's no open data, okay? Mobile phone, open data, Google search ka, there's no such like that in the examination, especially mga licensure examination, employer examination, okay? There's no such like that. Okay na, open ang imong mobile data, then hindi mo rin dyan siyang ikuha dito sa Google search. No, it's not. Okay? So that's the purpose of we need to memorize important, okay, basic concepts or any values or concepts to whatever pure substances or any common chemicals. Common lang din siya, okay? Or if you want, then it's up to you, okay? The better, okay? The more you memorize a lot and you put in your brains, the better, of course. Okay, so number 5, melting point, the reverse of freezing point. Okay, the melting point, a change from, okay, solid to liquid. Okay, but this liquid, guys, not necessarily only liquid, it could be also a fluid. Okay, because fluid is also a liquid. Okay, and a solvent also. Because sometimes it will be changed. Blank is a process, a change from solid to fluid. Or a change from solid to solvent. Yun na, solid to liquid, kaya the moment pero yung gibasa or gi-memorize. So, it's also melting point. Basta liquid form siya. It could be a solvent, liquid, and a fluid. Because fluid is a liquid, but only, only slippery, or, what do you call this one? Oily. Okay? Or have high density, something like that. Okay? Or viscous. Okay? The more it is viscous, the more it is turning to fluid. Okay? Something like that. Okay, number 6, tripod point. Wow! Grabe. Meron ng mga tripod point. Okay? It is a temperature at a given pressure of a particular substance, liquid, solid, and gas, in which they coexist with each other and then in a thermodynamic equilibrium. Wow! Equilibrium silang tatlo. Meaning to say, the fusion curve, the sublimation curve, okay, and the vaporization curve meets together if you have a phase diagram for water, for alcohol, like that. Known as a tripod point. If they will not coexist, and if they are not in equilibrium with each other, these 3 phases, then it's not called a tripod point. Okay, the term speaks tripod, 3. Okay, you get the point? It's easy to detect also in the multiple choice. But in the definition, You cannot easily guess because it's like this, okay? It is a temperature at a given pressure that the substances, solid, liquid, and gas coexist with each other in a thermodynamic equilibrium. So kung imo jud toki ono sabtan naman porque coexist man siya, okay? And then in an equilibrium. Not necessarily that, you know, there's a word tripole there, okay? So you could understand also. There are three phases. So, oh my gosh, tripole point. Okay? Number 7, critical point. Oh my gosh. Critical point. Critical point exists at a very high temperature and pressure, guys. Okay? It's beyond the maximum temperature and pressure considered for a particular substance. Okay? Like that. And then this is the time when there is a critical density, critical pressure, and critical temperature of the three phases. Okay, and then this is also the time that is very, very difficult to identify already if it is a gas or a liquid or a solid. Meaning to say, the distinction between liquid and a gas can no longer be made if this point will be attained or achieved. Okay, you cannot easily, this solid, these are liquid, this is fluid. No, it's not if that time comes. Okay, you cannot guess technically unless you can have a, you know, data. Okay, so that is a critical point. Get the point? Critical point. You get the point? Okay, so it's very easy. You can identify visually if it is a liquid or a gas like this. When this critical point has been reached. And this critical point, and you know, critical points are very important also in the non-ideal gas law, okay, in Van der Waals equation. Usually the very high good siya ng mga parameters. Okay? Grabe juga yung temperature, tag-as kay siya temperature. Okay? Critical nga. Okay? So, number 8, flash point. Flash point, it's basic also in chemicals. All chemicals has its own flash points. Okay, the ability to ignite, to cause a fire. Meaning to say this is really the lowest or the minimum temperature of a combustible gas or vapor in air that could easily ignite, okay, or producing a flash of fire in the presence of ignition source. Okay, this is a flash point. Your key terms are ignition. Okay, and then another is flash of fire. It will create, and then through ignition sources. Okay, that is flash point, and that is the basis for the flammability. How flammable the substances really are. Okay, like that. Number 9, auto-ignition temperature. O2 means automatic. And this is a combination between the automatic and the ignition. Actually, this is automatic ignition temperature, but it's only abbreviated as auto-ignition temperature. But by the term itself, it's automatic. Right? No need to add ignition sources. So, it is usually misinterpreted that is really close the definition to the flash point, but it is not, because this is also the lowest temperature and minimum temperature at which the combustible vapor or a gas ignites in air without the presence of ignition source. Meaning self-ragid niya, okay, ni create siya ignition dayon. Okay? Not necessarily na kay mga sparks, flame, na kay mga ignition i-ignite, no. Not necessarily. No external presence of ignition, but all ignite by itself. Like a self-ignition. Something like that, okay? Na spontaneous. Okay, spontaneous again, by its own, by definition in science. Spontaneous by its own, meaning reversible, okay? Like this. Get the point? Meaning to say negative enthalpy. Okay, negative H or exothermic reaction. It releases heat from the system to be absorbed by the surrounding. Okay? That's the definition. Okay, now we have explosion point. All chemicals also has explosion points. That's why we have so many accidents regarding explosion in different chemical plants all over the world. For example, in Chernobyl, Japan, there was an explosion there before, right? So this is the explosion point of a radioactive material. Okay? Radioactive material or nuclear reactions. So all nuclear chemicals or radioactive materials has a very high value of explosion points. That's why it can cause explosion. Normally, when explosion comes in, fire will follow. Okay, this is related with each other. Okay, but not necessarily fire will have always explosion. Okay, but all explosion has fire after. Goes together. But the fire, not all have explosion. It's only just a fire. Okay? The explosion is producing a sound. Okay? That's the meaning of explosion. Like that. But fire, not all the time will have like that. Okay? So that's the only difference between a fire and explosion. Okay? Explosion always have fire after the explosion. It will release smoke. Okay, of course. The black residues, which is mainly the carbon. Why? Because all chemicals has carbon atoms. You get the point? And carbon normally has a color black. You get the point? So that's when it has black color residues after burning. You get the point? Oh my gosh. That's the main reason behind. Okay? When you burn also sucrose or white sugar, you can find black residues. That is also for the carbon atoms. If we mean carbon, that is black. Okay? No other color is always black. Okay? Okay? And then the bright light will produce, it could either be orange, yellow, orange. Okay? But it depends also to the kind of substance that is burning. For example, if it is a neon element, it will produce also a yellow-green. It depends on the situation. Especially these inert gases or the noble gases, okay? In the last, you know what they call this one? Family in the periodic table. Okay? Family meaning the column, huh? Periodic meaning the row. Okay? And the family is the basis of the valence number, oxidation number, or oxidation state, and the charge of each element in the periodic table. Okay? Ganon. Okay, and then we have the fire point. What is fire point all about? Okay, this is really obvious also. Okay, but the definition is not obvious. For example, in an examination in the future like that, which of the following means or it is defined as blank is defined as the lowest temperature at which the vapor is continuously burning or keep burning after the ignition source is removed. There's no fire in the definition. It's very difficult to guess. With the point A, flash point, B, auto ignition point, C, explosion point, D, fire point, E, bubble point. Libog na kano. Blank. Okay, blank is the lowest temperature in which the vapor always keeps on burning after the ignition source is removed. So that is fire point. Di ba makalibog? Okay, so basically pala, it is the vapor that is firing, not the liquid. You get the point? When we mean about fire, the vapor and the gas is always the final point in distinguishing that phase is fire, is firing. Okay? Not the solid, not the liquid. For example, this wood will be burning, creates a fire. It's not the solid that acts as a fire, that produces the smoke and the bright light. It is the vapor or the gas. Okay? Because in the definition, the vapor keep on burning man siya. It's not the solid and liquid keep on burning kung na-remove ang ignition source. For example, na-remove naman siya ang ignition source. Okay, nangaabot ng mga fire truck, you stop at the fire station. So of course the ignition source are removed. You do housekeeping. Okay, like there's no ignition source anymore, but still have a fire because of the vapor. Okay, the vapor are burning, not the liquid, not the solid anymore. You get the point? So when we mean a fire point or a fire, it is the vapor that is burning continuously, not the liquid and the solid. But in initial stage, by visual inspection, normally this solid and liquid are burning. But the final identification technically and scientifically, it is the vapor or a phase of vapor or a gas phase is burning continuously, not the liquid and solid. Since we know combustible materials are solids, okay, and then flammable liquids also, but that is not yet a gas. Okay, like that. There are also a gas already, like the gas cylinders, you know. But what I mean for others, that is not a gas. Okay? Normally, vapor na siya eh. So, you got the point? So, dali masunog ang vapor with that technical information. So, the vapor or a gas usually easily be producing fire compared to solid and liquid. For example, oxygen gas cylinder, that is already a gas inside, right? It's not a liquid. So, of course, task and flash point, it will ignite to the air. So, meaning to say, it will burn easily, it will produce a fire easily compared to solid and liquid. Get the point? Okay, lighter, may good guys siya. Okay, sunog na yun. Okay? Because gamay na makikinetic energy kinahanglan. Okay, gas naman siya, light. It can be explained in science through molecules also. Because gas, the molecules are farther away with each other. So lighter, it needs only less kinetic energy, less heat energy to burn. Okay? Compared to liquid and solid. That's why gas, vapor will easily burn or easily create and generate fire compared to solid and liquid by science explanation. Okay? If we try to dig it out. Something like that. Okay? Thank you so much for watching this video and I hope you like it. And then you can click the notification bell for some new stuff that's on my signature voice. Okay? Thank you. Bye-bye. See you later. Oh my gosh.